most of the IGCSE students get confused between electrolysis of molten compounds and electrolysis of aqueous solutions. So in this video, we are going to clear your confusion. So as we discussed in the earlier video that we have two types of solutions. We have two types of electrolytes. One is molten electrolyte, and the other one is aqueous electrolyte. So both of them have different products on the cathode and anode. So let us understand each of them step by step. We'll be first starting with electrolysis of molten compounds. So when we take an electro compound, when we take a molten compound, for example, let us take NaCl. So when NaCl is in molten form, NaCl breaks down into Na plus and Cl minus. Now, during electrolysis, what happens is Na goes to Na, because it is cation, it goes to cathode, and Cl, chlorine, which is anion, it goes to anode. So electrolysis of molten compounds is very straightforward and it is very easy. Here we have an example of electrolysis of potassium chloride. Potassium chloride is KCl. Now when KCl is in molten form, you get K plus and Cl minus, potassium cation and chloride anion. So now during electrolysis, what happens is K plus ions are attracted to the cathode, and K plus ions gain electrons, and potassium metal is deposited. So what happens basically here is the K plus ions, they try to get neutralized. So K plus, to become neutral, what it does is it accepts electrons, or you can say it gains electrons. So when K plus it gains electrons, it becomes potassium metal. Okay. So potassium metal is deposited on or at the cathode. Now chlorine ions are attracted to anode because it is minus, anions are attracted to anode. So they lose electrons and become chlorine gas. So basically what happens here is Cl minus, it also tries to get neutralized. So it loses electrons and it becomes chlorine gas. So here, to form chlorine gas, Cl2, we need two chloride ions. So what we do here is we take 2 Cl minus, which gives 2 electrons plus Cl2 gas. Now, if I write down the ionic half equation for potassium ions, that becomes 2K plus 2 electrons gives 2K, like 2 potassium molecules. Yeah, sorry. You can say 2 potassium atoms in solid state. So what is happening here is 2 chlorine ions, they lose 2 electrons and they give us chlorine gas at the anode. Now this same 2 electrons, they are accepted by the cathode. That means the potassium accepts the 2 electrons and it becomes potassium solid. So this potassium solid is obtained at the cathode. So generally what happens is cathode is at cathode metal is obtained, and at anode non-metal is obtained. This is how the electrolysis of molten compounds happen, and this is how you write the half ionic equation. Let us understand the half ionic equations again. So during half ionic equations, you write the half ionic equation at the anode and you write the half ionic equation at the cathode. So generally what happens at anode is, at anode, 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 at anode oxidation occurs. At anode oxidation occurs, and at cathode reduction occurs. Okay. I hope you are well aware what is oxidation and what is reduction. So basically what happens at oxidation is At oxidation, there is loss of electrons. At oxidation, there is loss of electrons. And at reduction, there is gain of electrons. So always at anode, oxidation happens, and at cathode, reduction happens. Okay. So there is a small mnemonic to remember what happens what happens during reduction and what happens during oxidation. The mnemonic is oil rig. I hope you remember this. Oil rig. Oil rig means oxidation is loss. Oxidation is loss of electrons, and reduction is gain. Reduction is gain of electrons. Reduction is gain. Okay. So this becomes OIL, oil, RIG, oil rig. Fine. So this will be very helpful for you to remember that what happens during oxidation and what happens during reduction. And also remember, at anode, oxidation happens, at cathode, reduction happens. Okay. And at anode, you get non-metals. At cathode, metals are obtained. Okay. This is what generally happens during electrolysis of molten compounds. Now let us have a look at few past paper questions which are related to electrolysis of molten compounds. Now this appeared in 2023 paper 4 October, November. The question says, the student carries out an electrolysis experiment on molten lead chloride using inert graphite electrodes. So the question is saying that there is an electrolysis reaction. We are doing electrolysis with electrolyte molten lead chloride. And it says chlorine gas is formed at anode. As we have learned just now that the chlorine gas, that means non-metals, are obtained at anode. Right. So it is saying the chlorine gas is obtained at anode and escapes from the apparatus. It is asking us to explain why lead chloride needs to be molten before it will conduct electricity. So the reason here is that in the solid form, in the solid lead chloride, that means PbCl2, okay, it does not have any free ions. So it has no free ions. Okay. So ions cannot pass, or you can write this as the electrons, or you can write this as in solid state, the ions are fixed, cannot move. When molten, the ions are free to move and conduct electricity. So yes, you can so for this question, you can write that in solid form, they do not conduct electricity because we have no free ions. And in the molten form, we have free ions. Hence, they conduct electricity. You have to write this in the form of sentence. I'm just writing it so that you can get an idea about how to write the answer. Now, the next question is, name the product formed at cathode during this electrolysis. Name the product formed at the cathode during this electrolysis. So, as we have discussed, the electrolyte is PbCl2. In the molten form, it gets split into Pb plus 2 and Cl minus, right? So, by seeing this, we can say that this is the cation, right? So this is the cation. So at cathode, cation gets attracted. So at cathode, we get lead, Pb solid, right? So Pb solid is obtained at the cathode as metals are deposited at the cathode. Write the ionic half equation for the reaction occurring at anode. At anode, where the chlorine gas is produced. So, students, please be careful while writing your answers to the exam. Read the question properly. In the question, it is only asking you the reaction occurring at anode, right? What students do is they also write the reaction which is occurring at the cathode, which is not necessary. So please do answer what is being asked in the question. So according to the question, it is asking us to write down the half equation that occurs at the anode, or the reaction which occurs at anode. So at anode, as we discussed, the chlorine gas is obtained. So 2Cl minus, okay, 2Cl minus. As we discussed, at anode oxidation occurs. So oxidation is loss of electrons. So 2Cl minus gives 2 electrons plus chlorine gas, right? So this is the half ionic equation which is obtained at the anode. Next question, this appeared in the year 2022, October, November. It says molten potassium bromide is electrolyzed using inert carbon electrodes. State what is meant by the term electrolysis. We have discussed this in our video, the previous video, in the basics of electrolysis, that electrolysis is a reaction in which electricity is used to split an ionic compound. Okay. Second question is predict the products formed at the anode and cathode. Give the name of each product. So what are we using as our electrolyte? It is potassium bromide. Potassium bromide is KBr. Okay. Potassium bromide is KBr. So when it is in the molten form, you get K plus and Br minus. So what are the product formed at cathode and anode? We should only write the products formed at cathode and anode. It is not asking us the half ionic equation. It is only asking us what are the products formed. So you can simply write at cathode, you get potassium solid. At anode, we get Br2 gas. As simple as that. But it is very simple when you understand the concept, when you know the concept. So it gets very simple. If you are not aware about the concept, then things become difficult. So I hope this video was quite useful for you and you have learned from this video. See you in the next video.